All right. Hi, Megan. Hi, Lauren. Hi, Natalie. You just missed me singing the Come Back to Jamaica song, but I don't think the class wants me to do it again. So everybody's here. We're going to go over our tests. Everybody but you. 2, 4, 6, 8. Is that right? We're just missing Natalie. Is that it?
Yes, sir.
So hope you're having a great time. We're going to go over the test, and then we're going to start chapter 10 together today. All right, so thank you, Leah, for writing worksheet. Thank you for writing all the answers on the board. I think I want to go over the whole test. Okay, let's just work through it as quickly as we can. I'll get you to talk about it. So the first problem was solve using any algebraic method you wish. So Rebecca, the first problem on the test, 3k minus 2 quantity squared equals 49. The easiest way to solve that is to use what principle or property of mathematics?
The square root property.
Okay, so when we take the square root, we need to introduce
A negative or plus or minus.
plus or minus, and so we end up with 3k minus 2 equals plus or minus 7. We then add 2 to both sides, and we get 3k equals either 9 or negative 5. We divide both sides by 3, and we get what Leah wrote, k equals 3 or k equals negative 5/3. We could easily check both of those that they make the original equation true, and we would then know that we have both answers. Mr. Thomason, why were you expecting 2 answers to this problem?
Because you just do the plus or minus.
True, but if you forgot the plus or minus, why would you have expected 2 answers to this problem? What kind of an equation is this? Oh, you don't have your test. Look at Cayman's test. What kind of equation is this?
Perfect square.
It's a squared equation. So if you expand that binomial out, which I don't need you to do, but if you did, you'd have 9k squared, and then from there, what degree equation is 9k squared going to be? How many solutions is a second degree equation going to have?
2.
Up to 2. So you should have been looking for 2 answers, and when you only got 1, said, something smells fishy here. I'm expecting 2 answers. Why am I only getting 1? All right, number 2. Miss Adams, we have another quadratic equation. What method did you use for solving that one?
I did the quadratic formula.
Did the quadratic formula. And what did you get? M equals?
1 and 1/2.
1 or 1/2. Mr. Trice, did you use a different method?
Oh, yes, sir. I was just factoring.
You were able to factor it into 2m minus 1 times m minus 1. Very good. And you have to set it equal to 0 first. Why is that, Miss Jones?
So that you can use the zero factor property?
Very good. So factoring it when it's not set equal to 0 doesn't accomplish anything. It's only when it's set equal to 0. All right, Miss Lindsay, number 3, what method did you use?
I did completing the square.
Okay, so we did half of 6 is 3, squared is 9, so you added 9 to both sides, and you got x plus 3 quantity squared equals 15 plus 9 is 24. And then what did you do?
And then I used the square root property.
Very good, and you got x plus 3 equals plus or minus square root of 24. You subtracted 3 from both sides and got minus 3 plus or minus the square root of 24, but then you notice that 24 can be simplified further, and what did you do to simplify it? Or what should you have done if you didn't do it?
I took out the 4 because that is a square root.
Okay, so what is the square root of 4?
2.
2, and that leaves square root of 6. So your final answer, Leah wrote for us, negative 3 plus or minus 2, the square root of 6. All right, number 4, we had to use the quadratic formula, Cayman. Mr. Bond, so what did you end up with when you did that?
The answer?
Yep.
Negative 7 plus or minus square root of 37 over 2.
Good, so as long as you had the quadratic formula correct, and as long as you got the correct A, B, and C, once you expanded everything, combined like terms, you got it all to one side set equal to 0, you should have gotten negative 7 plus or minus square root of 37 over 2. All right, Mr. Ecton, number 5 on the next page, it said you had to complete the square. So this was going to be a problem because you had a 5 in front of the x squared. So you factored out the 5, and you got x squared minus 2x, right? And you put the minus 7 on the other side to get it out of the way. So now we need to take half of negative 2, which is negative 1. We need to square it,
1.
which is positive 1. And we do the same thing to both sides. So do we add 1 to both sides? No. Why don't we add 1 to both sides? Because of that 5 that we factored out, are you actually adding 1 on the left side? Or are you adding 5 times 1 on the left side?
5 times.
So what do we need to add to the right side? You need to add 5. So that was the only hard, tricky part, if you will, of this one. And we did these in class, right? Where we had a coefficient other than 1 on the x squared term. You had to be careful because you're not just adding 1 to both sides, you're actually adding 5 times 1 to the left side. Does everybody see that? So you need to add 5 to both sides. When you do that, you end up with x minus 1 squared equals negative 2/5. And so we take the square root of both sides, Hannah, but we've got a problem because now we have x minus 1 equals plus or minus the square root of a negative 2/5. Can we handle that now?
Yeah.
How?
Well, you would take the radical out of the bottom.
Okay, so we could rationalize the bottom and get the square root of negative 10 over 5. That's helpful. But we still have this problem of the square root of negative 10. What do we do with that? That's not even a real number.
Well, we could put I on.
There you go. So we can take out the square root of negative 1 as I and just leave I square root of 10 over 5. And that's what you end up with. 1 plus or minus I square root of 10 over 5. Or if you put it all over a common denominator, you'd have 5 plus or minus I to the square root of 10 all over 5. Those are your two options. Okay? And those were problems that you did for homework where you had square roots of negatives and you ended up with I in the answer. You had some of those for homework. All right, number 6, we're solving for S. I don't know where we're at, but Amanda, solve for S, and we get
Negative 5/3 and negative 3/2.
That's correct. How did you do that? You multiplied both sides of the original equation by?
S squared.
Good, and you end up with 6s squared plus 15 equals negative 19s. You brought it all over to one side, set equal to 0, and then what did you do? Quadratic formula, or did you try something different?
I did quadratic.
I did too, because I didn't think I wanted to do half of 19 squared. That looked like a problem to me. If that middle b term, Brogan, had been something other than 19s, right? I don't know where it is right here. If that had been something other than 19s, like 18s or something else that was divisible evenly by 2, then I might have done completing the square or whatever. But yeah, no way I was wanting to add 389 over 4 to both sides or something like that. That looked like a problem. So I did quadratic formula too. But they'll all work. And you'll get the same answer, whichever method you use. And you were free to use any method you preferred. All right, number 7, solve for D. Okay, we multiply both sides by D squared, and then we divide both sides by R, and then we take the square root of both sides. So when we do that, Matthew, we need to introduce plus or minus, and we get D equals plus or minus the square root of K over R. Leah, can we leave it like that?
No.
We can't. Why? Because we have 4 rules of simplifying radicals, one of which is you can't have
A radical in the denominator.
a radical in the denominator, or in this case, a fraction under a radical. And it's the same, it amounts to the same thing, doesn't it? Because if you have a fraction under the radical, Cayman, you can take the square root of the numerator over the square root of the denominator, and then you're back to having a radical in the denominator, which you can't do. So if you rationalize it, you end up with what, Rebecca? Plus or minus?
The square root of K R over R.
Very good. And Leah's got that written up there for number 7. All right, number 8, Miss Lindsay. What degree equation do we have?
4th degree.
How many answers are you expecting?
4.
Up to 4?
Up to 4, sorry.
Okay, and do we know how to solve 4th degree equations? Henry, did you memorize that quartic formula that I showed you that was like 3 pages long? You didn't memorize that quartic formula, did you? No. So we really don't have a good method for solving a 4th degree equation, except in this case we have a little trick we can use.
I have the row at the top, let p to the 4th equal p squared, and then when I got my 2 answers for p, I substituted that p for p squared.
Very good. Or you could just let p equal something like x squared.
Correct.
It's the same thing as what you did when letting p to the 4th equal. Did you say you let it equal p squared?
Mm-hmm.
I guess that's all right. You technically can't substitute the same variable for the but it actually works as long as you know in your head that what you're doing isn't technically allowed. But it still works as long as you remember to back substitute. If you don't, then you're in trouble. And what did you end up with? P equals plus or minus?
Square root of 7 is the plus or minus square root of 2.
And those are the 4 answers you're looking for. All right, let's leave those word problems for last. Let's do number 10. I give you an equation of a second degree equation. I give you the form of it where it's already in vertex form. And I ask you for the vertex. So it's going to be the opposite of negative 4, which is 4, for the x value or the h value of the vertex. And then the positive 12 is going to be the y value of the vertex, otherwise known as what letter is the y value of the vertex? K. Okay, so the plus 12 is the k value of the vertex, otherwise known as the y value of the vertex. All right, so the vertex is 4, 12. Does it open up or down, and how do we tell, Brogan?
It opens up because there's a number in front of the parentheses is positive.
Very good, and in this case it's positive 1, so it doesn't actually appear, but we know that's what it is, so it opens up. What are the y-intercepts? How do we find them? Well, we let x equal 0. If we let x equal 0, we get negative 4 squared is 16 plus 12 is 28, so the y-intercept is just, there's only one of them, and it's the point 0, 28. Okay? What are the x-intercepts? Now, if you're not sure how to do this, which you should be sure because we've done it with first degree, second degree, all kinds of different equations. How do we find the y-intercepts? We let x equal 0. How do we find the x-intercepts? We let y equals 0. So you let y equals 0 and solve, and oh look, it's just a quadratic equation, which you know how to solve when it's set equal to 0. So you just solve it. But if you didn't remember that, then one option is to say, what's the vertex of this parabola? 412. So we'll put it maybe here. Does it open up or down? And is it wider or narrower than our normal parabola? It's the same. So I'm only guesstimating here, but you see if I go like that and make a parabola, here's the y-axis, here's the x-axis. Where are the y-intercepts and how many are there? Well, just looking at the graph, here it is, and there's only how many? 1. So, and is it a positive or negative? It's a positive. Is it higher than this point, which is 412? It is, and now I may not have drawn it to scale or anything, but you're expecting the number to be bigger than 12, right? And so, okay, if you let y equal 0 and solve, what do you end up with? Well, wait, that was for finding, that was for finding the y-intercept. Sorry, we're on now x-intercepts. How many places does it cross the x-axis? None. So you actually don't need to do anything. You can just write, there are no x-intercepts. That was the answer for D. Now, if you actually put in y equals 0, then you're going to get x minus 4 quantity squared equals negative 12. Take the square root of both sides, and you're going to find there are no real numbers that satisfy it. There's only imaginary solutions to that. Okay, so in terms of the graph, what are the x-intercepts? Answer, there are no real intercepts. Real number intercepts.
When I did this, I learned where I found the discriminant,
Mm-hmm.
and if the discriminant is negative, then you know that you have two imaginary
Very good.
numbers. So I found it negative and did it that way.
Very good. Very good. That's excellent. All right, and then what is the range for this function? I was surprised at how many of you went with 4, which is the x value of the vertex, and said, oh, it goes from 4 to infinity. But wait, 4 is the x value, so the domain is all allowed x values, which is to say from negative infinity to positive infinity is the domain. What's the range? That is what y values can result. And the answer is y values that start here and get bigger up to positive infinity. And so a bunch of you had from 4 to infinity for the range, and what should it be? From 12. Y value of the vertex 12 to infinity. Okay? All right, last page, and then we'll go back to the word problems. On the right, I show you a graph and ask you for the vertex. And so you had two choices. You could either do our complete the square, modified complete the square trick, or some of you memorized the negative b over 2a, which you actually don't need to memorize because it just comes right out of the quadratic formula. Opposite of b, all over 2a. And so you would have what you need from the quadratic formula that you already have memorized, okay? So the vertex of the parabola ends up being -2, comma 4, comma -4, -2, comma -4. And if you check the graph that was provided on the test, does that look about right? -2, -4 is the vertex? Okay, so that was a nice easy check. And then the axis of symmetry is the line around which the parabola can be bent around in half and mirror image itself. So what is the equation of a vertical line, Leah?
It's gonna be 0 for
X equals something. And where's that vertical line going to go through in this case?
-2.
Good, because it's going through that vertex which you found to be -2, comma -4. Very good. So the equation of symmetry, the axis of symmetry is x equals -2. What's the range of this function, Henry?
It's going to be including -4 to -10.
Good, and we always write it in order of a number line. So what's the furthest left thing on the number line? Is -4 or negative infinity?
Negative infinity.
So you're going to write parenthesis negative infinity, comma -4, and then do we want a bracket or a parenthesis for the -4?
And closing bracket.
Good. So parenthesis negative infinity, comma -4 with a right bracket, not a parenthesis, because it includes -4. Now, will y ever get bigger than -4, Matthew? Will the y values ever get larger than -4? No, because the parabola at that point at the vertex now begins to turn back down again. Okay? Extra credit. For what values of x is this parabola greater than or equal to -10? Now look on your look on the graph given to you. Where does the parabola equal -10? Well, there's 2 points. You see them? They're both x values that are negative, right? So if you draw 2 little dots right there are the x values where the parabola equals -10. Now I'm asking for what values will the parabola be greater than that? So which direction? Below those 2 points or above those 2 points? Above. So you're looking for all the x values from this left point up to the vertex and back down to the right point where it equals -10. So to find the values where it equals -10, what do? Rebecca?
You said x can equal, but it's greater than, not greater than. No, -10 is less than or equal to the equation.
Well, you're going to have to be a little careful with that, but yes, that's sort of what you want to do. Why not just set it equal to -10 and find those 2 x values, and then say, I want all the x values starting here, going up, and including where I end over here. So instead of having to figure out the less than or equal to thing, and then have to figure out, like, if I divide or multiply by a negative number, I got to flip it around and all that. Why not just eliminate all of that work and just say, let me set it equal to -10, and that'll give me the 2 points, right? And then say, for what x values will it be greater? Well, it's all the x values in between those 2 points, but also including those 2 points. And what are the 2 points? Anybody get those?
-2 plus or minus square root of 2.
Very good. -2 plus or minus the square root of 2. And we got that, Rebecca, by just letting the function equal -10. In other words, letting y equal -10. Okay?
I was so close.
What'd you miss?
When I was solving, I had x squared plus 4x plus 2 equals 0, and then I did 2 plus 4 when I factored by the square. and I said the square root, -2 plus or minus the square root of 6 instead of square root of 2.
Okay, so you did 4 plus 2 instead of 4 minus 2. Oops. And but here's the thing, Cayman, and this is, we've been doing this since August. We all make mistakes. You made a little mistake with the 4 and the -2, and and you end up with the wrong thing. Plug those numbers into your calculator. What do you get? So your final answer was -2 plus or minus square root of 6.
Mm-hmm.
So what is -2 plus the square root of 6 on your calculator? And how long would it take you to check that? Go ahead and do it. -2 plus the square root of 6. He's getting his calculator out, so I won't start the timer yet. Rebecca, can you do it real quick? Ready?
Sorry.
Go.
What exactly?
Right. -2 plus square root of 6.
0.449.
0.449. Now, where's the x value, 0.449?
It's pretty close to 0.
Okay, but to which side of the
Oh, the right side.
the right side? And what's the y value going to be just a little bit to the right there? Is it going to be -10? It's closer to -20, isn't it? The point being that you know that the x value where y is -10, they're both going to be negative. You've just gotten positive 0.44. You know it's wrong. And that took you 5 seconds to check it on your calculator, and then maybe another 10 seconds to kind of evaluate it mentally to say, does that make sense that one of my x values is going to be positive? It doesn't work. It doesn't fit the graph. Therefore, let me go back, and then you would have found that, came in and said, oh, wow, man, what was I thinking? 4, I got to subtract 2, not add 2, and boom, now you're home free, and you got that one right, 3 more points.
Yeah, my thing in that part was that I didn't think I was going to get it right, so I was having problems on other ones, so I just said, let me try it.
Okay. And remember, that's a decision, but also remember now that you spent that much time solving that and you got it wrong. So to me, that's wasted time. And so what I'm encouraging you all to do is to not waste time by doing a problem that you're not willing to check. And so you almost have to train yourself to say, hey, if I'm not going to check this one, why am I even doing it? Because if I do it and get it wrong, I'm wasting my time. Now, some of you have a high enough grade that even when you don't have a chance to check something, chances are you're going to get it right most of the time. And so that's worth doing. But I think you're locked came into a certain range of scores on your testing, and it's not going to change if you keep doing the same thing. And the same thing is that we all make mistakes, and so you make some mistakes, and you don't always check your mistakes, but yet you're doing all the problems, and you continue to get in that range of scores. Now, on a good day, you might just make fewer mistakes and get a slightly higher score. On a bad day, you make more mistakes and get a slightly lower score. But you're still going to be in that range, and it's not going to change, right? Unless you just stop making mistakes. Now, how realistic is that to say my strategy is I'm just not going to make any more mistakes? It's not realistic. So my suggestion has been since August, get to know yourself and say, if that's likely to be what's going to happen, then I need to change my strategy. And my strategy might be, don't do a 3-point problem. That might take you 5 minutes and you might get it wrong. Spend the time on the ones that you're losing 8 points on because you didn't check it or you just had trouble with it. You follow? And so then, all right, yeah, you're giving up 3 points that you're not even going to try, but that's better than losing 8 points on one that you spent 10 minutes on, had some trouble with, but didn't have enough time to figure out. Let's be strategic about it, and you might then start to push yourself up into a slightly higher range, Kingdom, where you now might be 3 or 4 points higher on average than you've always been, which puts you in a pretty sweet spot, right? But it takes a change. You got to change how you're approaching these things, right? Now, if I give you unlimited time for a test like this, you guys are all going to do much better, right? But you don't have unlimited time, usually in life, and certainly not here. On your final, unlike your midterm, you don't have unlimited time. You have 2.5 hours to do your final. And the final is designed so that almost none of you can answer all the problems on the final. That's on purpose. Why am I doing that? Because I want you to show me how much algebra you've learned this year. Not just this year, but up till and including this year. So you're going to have 2.5 hours to earn as many points as possible by getting problems correct. How can you be sure a problem is correct? By checking it. If you're going to do problems on the final and not check them, you're going to get some right, you're going to get some wrong, and the ones you got wrong were all wasted time. Is that a good strategy? I don't think so, although I will make the caveat that there are some problems and some students who, because you basically are going to get, you're only going to make a mistake, less than 10% of the time or something, that's fine for you to do that. And there's also the reality that that there are some problems that are just easy enough that you can tell, I'm not likely to make a mistake on this. But please don't waste your time on ones that are hard if you're not going to check them. That's kind of my main point. All right, extra credit. There were 2 extra credits. The one we just did for the parabola. But how about the final one? Oh, no, there's one more page. Sorry. The final one, the final extra credit on that page. If the discriminant of a quadratic function is negative, that's a different question than if the discriminant of a quadratic equation is negative. Those are 2 different questions. What do you know about the graph of the function? And this is just straight out of your textbook, right, where they show you that for a quadratic function, if the discriminant is negative, which is to say it's always negative, then what do you know? Well, you know it's a parabola that never touches the x-axis. There are no places where you will get real numbers. Okay, so you know it's never going to touch the x-axis. And that's different than if the quadratic equation has a negative discriminant, then that's like saying the x-intercepts are going to be what? It's going to be 2 imaginary solutions, which is to say it doesn't ever touch the x-axis. All right, last page, just a quick little matching. Bunch of equations, and you just need to identify the graphs. You guys did well on this. BDAC is the order of this, and you can look at the details later. All right, we want to do the word problems. How many of you did both word problems, 10 points each? Okay, how many of you did just, well, the rest of you did just one of the word problems for 20. How many of you did number 9 for 20 points? 3. How many of you did number 11 for 20 points? 2. Very good. I set it up that way because for those of you for whom time is a factor, that gave you the opportunity to not spend the extra time doing 2 word problems, but doing only 1. And I hope that that was helpful. All right, so let's do both of these. Greg can process a stack of invoices 2 hour. Ooh, that's a typo. Did anybody find that? That would have been worth 1 point to you. Did you circle it? Awesome. Did you make it so I could obviously see it? Because I don't think I gave you a point for it, did I?
You did.
Oh, look at that. Yeah, you gotta like circle it and put like blinking neon lights so I can find it. So catch me after class, Leah, and I will add a point to that. Is yours obvious that I'll find it?
No, maybe.
Okay.
I think
If I give it back to you and I forget when I grade it, then just remind me. All right, so 2 hours faster than Carter can. Okay, so what do you want to make your variable, Rebecca? You want it to be Carter or Greg?
For me, I did Carter.
Okay, so you let your variable be Carter. So we always define our variables, including units. So what variable did you use?
X equals Carter's rate and invoice.
Are you letting this be his rate, or are you letting this be the number of hours it takes him to process a stack? Those are 2 different things. So Carter takes X hours. So this is the number of hours for Carter to process a stack of invoices. And do I need units, or do I already have it? Already got it. Number of hours. So Greg can do it 2 hours faster, Brogan. So do I want X plus 2 if he's faster?
X
Oh, because it's the number of hours, and I can do Greg's number of hours, and you can write it out more fully than that. You see how it has to be x minus 2 for the number of hours it takes him. He's 2 hours, he can do it 2 hours faster. So what's Carter's rate, Rebecca?
1 over x.
1 over x. Why? Because let's say it takes him 10 hours. How much can he get done per hour? 1/10 of it. So you just take it 1 over that is Carter's rate. And what's Greg's rate going to be? It's going to be Greg's rate. Now what we want to know is how long would it take each person working alone. So we're going to try to find x, and we're going to try to find x minus 2. But they tell us that working together, it would take them 7 hours to finish the job. So there's a couple ways of doing this, but if Carter's rate is 1 over x, how much can he get done? How much work can he get done in 7 hours? 7 times that. And how much, if Greg's also working for 7 hours, how much work can Greg get done? And then what do I do if I want to show them that they're working together? And what are they going to get done in 7 hours? One job. And then you guys know how to solve this. Multiply both sides by x times the quantity x minus 2, and then you have a quadratic, and you solve the quadratic, and you get as your answer x equals 8 plus or minus 5 the square root of 2 when you simplify everything. So, what is 5 times square root of 2? It's going to be 7 something. So one answer is going to be 1 point something, which is going to be possibly Carter's hours. Now Greg's hours would be 2 less than that, so Greg's hours would be a negative something. So is that a possible pairing? So we eliminate this one, and we take only the positive. And 8 plus 5 to the square root of 2 is 15.07. And what is that going to be? That's going to be the number of hours for Carter, because we said x equals that, to process a stack of invoices. And so the question was, how long would it take each person? So you're going to write it in a complete sentence. It would take Carter 15.07 hours, and it would take Greg, who does it 2 hours faster, 13.07 hours. Now, if you want to really impress Mr. McGowan, you say, hey, I remember that he said, don't leave it in decimal form. So how do I convert this to minutes?
You multiply by 60.
Multiply by 60, which is going to be 4.2 minutes or something like that. So we're going to have 15 hours, 4 minutes, 0.2 times 60, 12 seconds. Now, most of you rounded this to 15 hours. Now, if I'm paying you money, do you want to report to me 15 hours, or do you want to report to me 15 hours, 4 minutes, and 12 seconds? You want to get paid for the extra 4 minutes, 12 seconds? So then on your tests, don't round it to 15 hours, round it to the nearest second. Do you need to round it to the nearest hundredth of a second? Millionth of a second? We use hours, minutes, and seconds, so the nearest second is a fine rounding. Don't round it to the nearest hour. Okay? Yep.
I did x plus 2, and I had Greg be the variable.
Good.
So my, and I got 2 positive answers actually.
Okay, that doesn't sound... Well, actually, no, that would actually... Go ahead.
And one was like 7.07, and one was like 13.07. And I just figured out that like it wouldn't make sense for one of them to take 7 hours, but it takes 7 hours together. So I figured it must take more.
Very good. Very good. So you ended up with a different quadratic equation when she let x be Greg, and Carter would be x plus 2, which means that he's 2 hours faster. She ends up with a different quadratic equation, which is to say a different parabola. So her solutions are going to be different, right? But her final answers are going to be exactly the same. Well done.
So could you help explain, so I got 13 and 15, and for some reason I said the rate for individual was 1, I do it handed 1 over x plus 2 and 1 over x. And I said Carter was 1/13 and then Greg was 1/15. seconds or something like that.
Okay, so have you given how long it would take each person, or have you given their hourly rate for each person?
Did I get the hourly
You
rate?
gave the hourly rate for each person. So the question was, how long would it take? So 1 over 13 is going to be 0.0 something hours. So you're telling me they can get it done in, a matter of minutes, or is it going to take 15 or 13 hours?
Okay.
So I gave you probably at least 4 points out of 10. How many total did you get? I gave you 4 out of 10. So you actually had solved it, but you didn't answer the question that was asked. And that's the last thing in our 6-step process, that we check the answer in the original problem. And of course, step 1 is, what are they asking us for? And Rebecca, they weren't asking us for rate, they were asking how long it would take each person, which is number of hours to get the job done. Okay? And then the last one is the river problem, so let's do this one. In 4 hours, Kara can go 22 miles upriver and come back. Okay? So she's going to go up the river and back in 4 hours. So here's a river. Okay? She's going to start here, she's going to go to there, and then she's going to turn around and come back. And the whole trip is going to take 4 hours. So Amanda, does that mean that each way takes 2 hours?
No.
It doesn't. You can't just divide it in half, because she's going faster when she's with the current and slower when she's against the current. She's going 22 miles river, upriver, so this distance is 22, and then she's going to go 22 miles back. So she's actually traveling a total of 44 miles. The speed of the current is 7 miles an hour. Okay? They want to know, what's the speed of the boat in still water? So let's let that be our variable, which 99% of the time is what we want to do. Only if it makes it more complicated or so on do we not do that. Hey, Cameron. So we got x is the speed of the boat in still water. And what's our units?
Miles per hour.
Still water in miles per hour. Okay? So what's it going to do when it's with the current? Equals speed of the water with the current. What's it going to do against the current?
Explain some.
Speed of the boat going against the current. Okay? So now, we're going to ask ourselves, how long is it going to take going in each direction? Well, what's the total distance going, let's say, against the current? 22. So if distance is rate times time, then we can go 22 miles an hour when we're going against the current. Okay? So what is our rate when we're going against the current? If this is the speed against the current, what's our rate? How do I figure out the rate? It's like a work problem. How do I find the rate if my speed is... Actually, let me redo this variable then. Let's do her speed.
I like that.
You like that? The speed, so I can live with that. But here's the thing. Let's do it this way. Let's do, if we want to know what the time is, let's solve for time. And what are we going to have? Distance over rate. So that's what we're looking for. So now if I want to know the time for, I'll just write it in words so we don't introduce a new variable. Time against the current. What's it going to be? It's going to be my distance over my rate. And what's the distance? And what's my rate against the current? So this is going to be what? The time going against the current. Now let's do it again. What's the time going to be going with the current? Brogan, my total distance going with the current is 22. What's my rate going with the current? So I got that from solving my formula for time. Now if I've got the time going against the current and the time going with the current, what do I want to do to find the total time? Is the time equal to each other? This is going against the current, this is going with the current.
So it would be, so you would add them and get the total time.
Okay, good. And what is this part, whole? So this is against the current part, with the current part. Add the two parts together and go back to the original problem. How long does it take to make the whole trip?
4 hours.
It takes 4 hours to make the whole trip. Part, whole, right? This is the time part going against the river. This is the time part going with the current. If I add the two parts together, I get the whole time for making the whole trip. And how many hours did it take to make the whole trip? It took 4 hours. And then again, you guys know how to solve this. Multiply both sides by the common denominator, et cetera, and you get x equals 11. Plus or minus the square root of 317 over 2 using the quadratic formula. And then what do? I use my calculator to get the square root of 317. I add it to 11, divide by 2, get an answer. What happens if I take 11 minus this? You get a negative number, so we can cancel that one out, and we're left with just the one answer. Okay? And the answer, did you have it up here somewhere? Did I erase it? The answer here is approximately 14.4 is our x, which is the speed of the boat in still water in miles per hour, which is what they're asking for. So we're going to write a complete sentence. Right? X is the speed of the boat in still water is 14. I didn't write that because I'm lazy, but we write the complete sentence. Any questions about that word problem? All right. So let's take stock of where we are. We're going to start chapter 10 today. And there are only 12 chapters that we're going through. There are 6 sections in this chapter. We're not going to get too much done today. So we got Wednesday, Friday, Monday, Wednesday, Friday of next week, Monday of the following week, and so our test will be likely Wednesday or Friday of that following week. Okay? And we'll figure it out for sure by the end of this week.
When are we going to go over 9.7?
We're not. I'll do it right now then. You ready? That extra credit problem on your test that said where will it be larger than, that's where the extra credit problem came from. Where will it be larger than or less than, etc. What you're doing is you're basically finding an interval and then evaluating whether you want it to be greater or less than those points that define the interval. And so in that sense, there's no new techniques or skills. It's just applying it to that extra little bit of question. And so really it's just the extra credit problem. And that's why I made it extra credit, because you didn't do it as a regular thing. All right, so chapter 10 is going to deal with exponents and logarithms. But particularly we're going to look at functions that are called exponential or logarithmic. Now, an exponential equation is not an equation that has an exponent in it, because we've already got quadratic equations with an exponent in it, and they're not exponential equations when you do that. They are just second-degree equations, okay? But an exponential equation or function is going to be an equation that has a variable as the exponent. See the difference? We're taking a variable and raising it to a power. That's simpler than taking some number and raising it to a power that is a variable. That's more complicated. Okay? So we're going to deal with equations that have an exponent that is a variable, and those are called exponential equations or functions, depending on how we set them up. Okay? But before we get to that, we're going to deal with the question of having an inverse of a function. Easy definition of the inverse of a function. The inverse of a function is when you take every point, that's the graph of that function, and you reverse the x and y values. That's what it means to take the inverse of it. So for every point on the graph of your equation, you reverse the x and y values. So the way to find the inverse of a function is to just take the general form of the equation for that function and reverse the x and y values in the general formula. So you don't actually need to have every point to do this. You can just do it in the equation. So if you say y equals x squared, reverse the x's and y's. What are you going to get? X equals y squared. You see? That's how you're going to invert these things. Now, there's a problem though. The problem is, how did we define a function? Oh boy, that was a long time ago. How do we define a function? Well, a function is a relation, is the technical word, very good, is a relation in which for every x value there is only one corresponding y value. And how did we test for that, Leah? Do you remember?
We plug in something for x and see if we only have one.
Good, and we're going to do that for every possible x value. So we had another way of testing it that was a little bit easier. What was that? You remember, Henry?
The vertical line.
The vertical line. We said, are there any vertical lines that we could draw that would cross through 2 points? Because if so, it would violate the definition of a function. Well, here's the problem. Let's say I have a function, and I'll make it nice and easy, and say, let me use a different color, and say it's this horizontal line right here. Ding, 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 ding. And how do I write the equation of a horizontal line here?
X equals
That would be a vertical line like we had on the
y
test.
equals
Y equals, in this case, what's it look like?
0.
Well, y equals 0 would be the x-axis, so what's this line? Well, let me draw a scale for you then. Let's say y equals 4 for this scale. I was going to let you pick the scale. It could be like y equals 100, and the scale would be... Yeah. So y equals 4 is going to be this line. Now, if I want to invert this thing, what's the x value right here, Brogan?
0.
So I got 0, comma 4. Henry, what's the x value here? Okay, so we'll call it 4, comma 4. And I can choose one out here. Let's just pick this one, Amanda. What do you think it looks like?
6, 5, or negative 5.
Negative 5, comma 4, that's fine. Now, if I want the inverse, what do? I swap the x and y values. So now I can make a chart for my inverse. Right now, I'm only going to have 3 points in my chart, but hey, that might be enough. So let's do, instead of y equals 4, I'm going to do x equals 4, and instead of x equals negative 5, I'm going to do y equals negative 5. So I'm going to invert all of my points. You see what I did? Now, I'm going to draw these points on the graph. 4, comma 0, 4, comma 4, 4, comma negative 5. And can anyone see what we've got going on here? What have I done? I've inverted this horizontal line, and it's now a vertical line. Does the vertical line pass the vertical line test? So if I draw a vertical line through this point here, will I hit any other points? And is that a function if I can hit more than one point for the same x value? It's not a function. So the problem I have here is that I can invert this function, but the resulting graph is not a function. You see that? The original was a function. I can invert it, but now I don't have a function anymore. Why do I care if I have a function or not? Because functions have certain properties that are very, very useful in mathematics. And if you can't say you have a function, then for a certain x value you get all different y values. You now have introduced all this uncertainty. Like if I put in x equals 4, what's my answer, Amanda? And you're like, well, it could be anything. Well, that's not so helpful to me. I don't want my answer to be, it can be anything. I mean, if that's what it is, that's what it is, but I don't want that. So I'm going to exclude functions that don't allow me to get a function when I invert them. Okay? And so how do I know which ones to exclude? Well, let's do it this way. if I draw a parabola and then I invert it, not a very good parabola, it's going to keep going bigger. Do I now have a function? What if the original parabola was an upside down parabola and I invert it? Do I have a function? So what can we exclude? All parabolas, which are what kinds of equations? All second degree equations are going to be excluded from being invertible such that it results in a function. Oh, we just eliminated a whole class of second degree equations. I don't know if that makes you happy or sad, but they're gone. If we want functions that when we invert them still give us a function. We just kicked out all the second degree equations. They're out of here. How about first degree equations? How do they graph? Straight line. So what kinds of lines are going to be invertible? All of them except for horizontal lines. Okay. Is a vertical line a function? So we're going to eliminate horizontal lines and vertical lines because while you could invert this one and get a function, it's not a function to begin with, and we want it to be a function both at the beginning and at the end. So we're going to say all first degree equations are fine as long as it's not x equals something or y equals something, which are vertical and horizontal lines. Okay? So what we're going to do is we're going to say that functions that are invertible and result in a function, we're going to call them one-to-one functions. And those are the ones that we want to work with because those are the ones that are functions to begin with, they're invertible, and the result is a function. That's what we want. Okay? Now how can we test that it's a function to begin with? Have you said it before?
You can graph it and then see if it passes.
If it passes the vertical line test, okay? How do we tell if it's a function after we invert it? It passes the vertical line test. Can anyone think of a test that we could do before inverting it that would tell us whether it will pass the vertical line test after inverting it?
Well, to pass the vertical line test, it has to have I'm trying to figure out how to put this. It can't be the y value forced there to x values because then that would make a line.
That's right. That's exactly right.
I don't know how you would find that.
What kind of line would it make after you invert it? It would make a vertical line that goes through more than one point. How could you test for that in its original form before you inverted it?
Horizontal line.
Do a horizontal line. So you're going to do the vertical line test before you invert it, well then you need to do a horizontal line test. So to tell whether it's a one-to-one function, do both tests, vertical line test and a horizontal line test. And if it passes both of them, then you're going to have a one-to-one function, which is to say it's a function to begin with. Go ahead and invert it, and it's still going to be a function. Because at this point now, there are no vertical lines that go through more than one point, which is to say that before you inverted it, there are no horizontal lines that go through more than one point. When you invert it, it still works. Okay?
On an inverted line, are they two lines, the before and after, always going to have 1 point in common?
Good question. Good question. Here's what's cool about this. I almost don't want to spill the beans because it's actually pretty cool. I wanted you to kind of come to it on your own. Let me think about how to answer your question. You've only got 1 minute and 15 seconds. How about we do it on Wednesday? Can you remind me that that's what we're going to do? Like right before class, remind me that that's what we're going to do. All right, so for homework, you're going to do just a little bit of 10.1, okay? So, let's see. Yeah, you can do up through 20, I think. Okay, so 1 to 20 is all that you can do at this point. And then we'll pick it up with Henry's question on Wednesday. All right? Any other questions? You got 30 seconds. Say goodbye to Natalie.